This video is for Stat 210, handout number 8, and we'll cover pages 1 through 8. All right, let's go ahead and get started. So what handout 8 is about is inferential methods for tables. In particular, we are going to be covering the chi-square test of independence in this handout. That's where we left off in class. So again, we have data from the Minnesota Department of Education regarding the use of marijuana. The data that we're going to be looking at here is going to look at the relationship between males and females and their specified risk of smoking marijuana once or twice a week. The research question: do differences exist between genders in the opinions regarding marijuana use for grade 12 students from Fillmore County? So we're going to make comparisons here between the males and the females and their level of risk. So this data, again, can be obtained from the handout number 8 Google folder, the file here. So let's open that file inside of Jump. In Jump here, I'm going to select Open. And then we're doing the grade 12 male-female comparisons. Say Open. And that file should successfully open in Jump. To get started with our analysis, we're going to go Analyze, Fit Y by X. The primary variable that I care about, or the response variable, is going to be the risk level. I want to make comparisons of that risk level across the males and females. So that's going to be my factor variable. And then also I need the counts down here in the freak box. So risk level in the response, gender as the factor, the count down here in the freak box. One thing that's going to happen when we get our display in Jump is that the responses have a particular ordering to them. So no risk, slight risk, moderate risk, and great risk. Now Jump doesn't know that a particular ordering exists, so let's go ahead and fix that graphic so this is in the correct order. To do that, I need to right-click on Risk Level, Column Properties, and do a Value Ordering. So Column Properties, Value Ordering. And here I can put them in a particular order. So I want to start with no risk, and then I want slight risk, then moderate risk, and then great risk. So now they're in that correct order. And what's going to happen after you get them in a correct order is we're going to get a little icon next to the risk level variable here in Jump. So that'll tell you that there's some sort of setting on that variable. And in particular here, it's just the ordering. Okay, so let's quickly remake that graphic, and things should be in the right order now. So now we can see that we start with no risk, slight risk, moderate risk, and great risk. We'll clean up our table a little bit. We will only be using the row percentages. So from the drop down here, we can get rid of total percent and column percent. We'll now go back over into the handout, talk a little bit about what we're seeing here with that output. So on the right-hand column here, we have the males, and the left-hand column, we have the females. And then the response, again, levels are great risk, moderate, slight, and no risk. So we can see here that a majority of females from grade 12 in Fillmore County believe smoking weed is of great risk. If we wanted to get that exact percent, we would simply look at the row percentages for females. So there were a total of 61 females, 35 of which specified that smoking weed at least once or twice a week was of great risk. So 35 divided by 61 is how Jump is getting that 57.38. Likewise, for the moderate risk box, for the females, that would be taking 15 divided by 61. So the height of this box right here is 24.59%. For the males, there's slightly less females, only 59. So 28 specified great risk. So 28 divided by 59 is a little bit short of 57% here. So that's the height of that box. So one thing that we can see is there's a pretty substantial difference between the males and the females in the no risk box. So there's a larger percentage of males believe smoking weed at least once or twice a week is of no risk compared to females. That only looks like it's about 5% here, and it's about 15% here. So the relative risk ratio there would be 3 between those two comparisons. So males are 3 times more likely to specify no risk compared to females. All right, let's go ahead and do the statistical test. What we're going to do with the statistical test is determine whether or not I have differences between the males and the females. So do I have statistical differences in the pattern that's on the left compared to the right? So if there were not statistical differences in the patterns, page 3, then this is the mosaic plot that we would end up getting. So what this chi-square test of independence does is tries to figure out whether or not this pattern that I'm seeing here, the observed pattern, is statistically different than the no difference situation. Okay, so how do we obtain the no difference situation? So a little bit about how to obtain the expected cell counts. Now actually JMP will compute these automatically for me. So I can, from the drop-down menu inside of JMP, just ask for the expected counts here. And those values will be provided there in each cell. So each cell has an expected count. So for females, that value is 6.1, and for males, that value is 5.9. So how are those values obtained? When we are looking at a no difference situation, we're not going to worry about what group they're in, whether or not they're a female or a male, because there's no difference between those. So I observed that I have a total of 12 people that specified no risk out of the 120. Okay, so 12 out of the 120 is 10%. So the first thing I do in thinking about those expected is compute the proportion of people that said no risk, proportion that said slight risk, moderate risk, and great risk. So again, 12 divided by 120 here for no risk. For slight risk, it's going to be 16. Again, there were a total of 16 individuals that specified slight risk out of a total of 120. So once I have those percentages for each of my response outcomes, now I'm just going to determine how many of these 12 should be male and how many of these 12 should be female. Okay, so there were a total of 59 males. If there's no difference between them, then what I'm going to do is put 10% of those 59 into this box. I'm also going to put 10% of the females in this box. So if I take 10%, because again, that's what the proportion is under no risk. So 10% times 61 is going to give me 6.1. 10% times 59 is going to give me the 5.9. And that is indeed what JMP gives me for those values there, 6.1 and 5.9. We're going to do that same thing for the slight risk. So about 13.3% of the individuals specified slight risk. So I'm going to put 13.3% of the 59 in this box right here, and 13.3% of the 61 in this box here. And I'll just continue to do that for the remainder of the boxes. So again, what that chi-square test is doing is looking at a difference between the observed graph here and the expected graph computed under no difference. The chi-square statistic simply takes the observed number here, which is 3 for looking at females no risk, The observed number here is 3. The expected is 6.1. So it's going to take 3 minus the 6.1 and square that, and then divide by that 6.1. Again, that denominator just helps scale each of those cells. So the cell contribution, okay, or that calculation for this particular cell is 1.57. Now we call that the cell contribution to the total. So if I add up all of these across all of the categories, I'm going to end up with my chi-square statistic, which is 3.78 in this case. So if I take the 1.57 and add it to the 0.0022, add it to the 0.0045, to the 0.2764, and do the same thing across the males here, add all that to 1.62, keep adding all of those cell chi-square values. I need to add that up over all of the cells or all of the categories. I'm going to end up with 3.78. Now we can see that a lot of that 3.78 is coming from the no risk category. It's 1.5 here and 1.6 there. 1.5 and 1.6 is what, 3.1? So almost all of this test statistic value is coming from that no risk group. And that makes sense here because the largest discrepancy that I have is in that no risk group. You can see here that on the slight risk group, those boxes look about the same and are close to the expected here. Likewise for the moderate risk, those two boxes are pretty similar to one another and are close to the expected here. The biggest discrepancies are in that no risk group. The p-value then is just how extreme is this 3.78 against my chi-square distribution. The degrees of freedom here are 3, and that is needed to draw that chi-square distribution. I provided a link here of a website that'll do that for you. The p-value is simply the probability or the chance that I'm going to see something greater than my test statistic. And we can see that 3.78 is not that extreme in this distribution. So 3.78 is really not that much of an outlier. So it is not less than the 0.05 cutoff or threshold value that we would use. So we do not here. We want to write a conclusion for this. We do not have enough statistical evidence to say, and then let's just go up and get the research, just page up here a little bit and get the research question. So we do not have enough statistical evidence to say differences exist between genders in the opinions regarding marijuana use for 12th graders in Fillmore County. And the p-value for that, we're going to use the Pearson p-value, 0.2862. Again, there's 3 parts to this conclusion. What is your decision? What are you making a decision about? And then what is your level of evidence? All right. Next example. Similar type of situation here. Same context, except we're going to be comparing grade 9 to grade 12. Okay, so 9th graders compared to 12th graders. So the null and alternative hypothesis are written here. So are there differences in opinions between grade 9 and grade 12? Still talking about kids from Fillmore County. So the observed data here is in this table. Again, we need to take that observed data and put it into JUMP. If we go back to our folder, you can see that data is there. So go ahead and download that data and open that in JUMP. Go ahead and close the other one just to not be confused by output. We're going to have to reorder the columns again, so let's do that quickly. Again, indicated with that little star behind that particular variable. So now we're able to create the graphic. Risk level again, grade level. Don't forget to put count in the freak box. And here I got the output. Grade 9 on the left side and grade 12 on the right side. Now we have some differences here. In particular, the proportion that said great risk in 9th grade was about 75% or 73%. So quite a substantial number of students believe smoking weeds once or twice a week is of great risk when they're in 9th grade. Now that slides back a little bit when we go into 12th grade. So there's certainly a change from grade 9 to grade 12 here. You can see that there's a big shift in the slight risk group. Okay. There's not hardly any slight risk over here in grade 9, but there's quite a few here in grade 12. One interesting thing is I don't have much difference in the no risk group. So what that means is if kids do not believe smoking weed's of great risk, they're making that decision before grade 9. Because that pattern there is pretty much the same between grade 9 and grade 12. If we want to look at which cells contribute the most to my test statistic, again, we would just be getting this cell chi-square. The slight risk there, 6.98, and then down below for grade 12, 10.00. So of that 24, this time a bunch of it is due to that slight risk group. Again, because those are so different from one another. The no risk group is not contributing very much at all to that overall test statistic of 24.105. The contribution there is quite small. We do get quite a bit of contribution as well on the great risk group. The p-value, Pearson's p-value here is less than 0.0001, just certainly less than 0.05. So back here on the handout, page 6, I will let you go ahead and answer questions 1 and 2 there. Again, this test is looking at the observed counts against the expected counts under a no difference scenario. The p-value here is less than 0.001. And there's the table with the cell chi-square values. So is my p-value less than 0.05? It certainly is here. So that's going to be the decision. And then writing a final conclusion, just kind of in everyday language. Go ahead and do that. It's going to be much like the one above, except here I have a different decision. So here we do have enough evidence. Okay, we want to make sure we do have enough evidence to say differences exist between, and we're doing this between grade 9 and grade 12. Sorry about that. Bring that up on this page. Between grade 9 and grade 12 and the opinions of marijuana use in Fillmore County. And the p-value here, I don't care how you write that, but it's less than 0.001. All right, so that would be the conclusion for that analysis there. Now, one thing that we talked about before spring break, is that these tests are two-sided. So the standard test that we have, the standard chi-square tests, are all two-sided. And here, in this particular example, we're probably more interested in a one-sided test. In particular, can I say that the trends have, or the proportions here, have slid down the scale a little bit? So the proportion's getting less here for great risk, and maybe potentially getting more here for slight risk. So do I have a pattern? Okay. Is there kind of an upward trend in this plot? I don't know if I can easily submit the not going to be able to do that quickly. So do I have a upward trend in this plot? Now our standard chi-square test, our test of independence, can't do that because the standard test is two-sided. However, JMP has in it something called a test for trend. So again, if I would have paged down, I would have had my arrows. Do I have a test for trend here? In other words, do I have a upward trend in this plot? And that test is called a Cochrane Armitage trend test. We can get that inside of JMP here. So from the red drop-down menu, we can do that test. Now this is not a typical test. This is not a common test, I should say. It's kind of neat that JMP has this in here for us. And then down here, it gives me a p-value. Okay, so that p-value right there says that I do have a test, or I do have a significant trend in this plot. Okay, so that's the Cochrane Armitage trend test. Again, that's not a common test, but it's something that JMP has in it. And in this particular case, we would maybe use this test instead of a test of independence. One thing I should say is the prob bigger than just z is the one-sided p-value, which is the one we'd want to be using here. So not the two-sided p-value, not the one that's bigger than absolute z, but just one side of the distribution. So the p-value here would be 0.005. So the difference here is I can say with the Cochrane Armitage test, I can say that grade 12 actually has weaker opinions regarding marijuana use. Or again, they've slid down on that scale, that no risk through great risk scale. All right, that does it for Handout 8. Thank you.